Bom dia a todos. A nossa primeira palestra de hoje será proferida pelo Dr. Dumont, da Clínica COS, na França. Ele, na Clínica COS, há a maior experiência internacional com próteses implantáveis de orelha média, e ele vem hoje compartilhar um pouco dessa experiência conosco. Dr. Dumont.
Thank you very much for inviting me to speak here in the Brazilian Congress. So, the field of middle ear implants is a very interesting and expanding field. I work on this subject since 1990 and started in the COS clinic with middle ear implants in Newman in 2000. So, as you know, middle ear implants are implantable hearing aids in which the transducer to stimulate the inner ear is no more a loudspeaker like in air conduction hearing aids, but an implanted vibrator implanted in the middle ear to stimulate the inner ear. Vilska in 1933 was the first to try to stimulate the inner ear by an implanted vibrator. That means by mechanical stimulation with a magnet that he put it in on the tympanic membrane and a coil to vibrate the magnet. The subject ear sounds, but the coil burned their auditory canal, and so he gave up. The modern area middle ear implants started in 70s with a team of Yanagiara and Suzuki in Japan with a technology of piezoelectric vibrator for their implant. Piezoelectric vibrator are ceramics that can change of form when you put electric current in it, or that can create electric current if you change the form of the crystals. There is actually two technologies to build vibrator implantable in the middle ear: piezoelectric vibrators and electromagnetic. The advantages of piezoelectric are a very low energy consumption, a reversible function. You can use it as a vibrator or to catch vibration. They are very good frequency response, and their design is simple. The disadvantage are that they are less powerful than electromagnetic one, and their power is size related. The other technology is electromagnetic vibrator that are the more powerful vibrators with good frequency response, but the energy consumption is higher and their design is more complex. The first era, modern era, was the experimental era with a lot of projects for implantable middle ear implants. These projects were described. There was animal studies, but no more. This example with a magnet on the tympanic membrane and a stimulating coil in an ear mold. There was other project with magnetic top and pops with a stimulating coil in an ear mold. Another one with the magnet implanted in the middle ear on the ossicular chain and the stimulating coil in the ear mold. This project went to the Sontec, we will see. Another project of Maniglia in Orlando with a magnet glued on the incus and the stimulating coil in this part with a quite complicated device, as you can see. This is also a description of the device of Maniglia. All that devices were designed, tested in animals, cats, or monkeys, but no more. This one is quite funny with the project of a totally implantable middle ear implant catching sound on the malleus with a very special spring and microphone, and stimulating the middle ear with a fenestration of the lateral semicircular canal. It never worked, in fact, in reality. This is a special design of the spring to catch the sound. This project was more realistic and went to the clinical use, developed by Frederickson with electromagnetic vibrator and a probe tube which is designed to be placed on the incus. Here, an artist tube with the electromagnetic vibrator shaft which go on the incus. Another research program was performed by Jonathan Spindle. He worked on stimulation on the round window, placing magnet on the round window with stimulating coils on the mastoid cortex. This is another experimental project on guinea pigs. You see here piezoelectric vibrator ending on the round window of the guinea pig. Here's the cochlea of the guinea pig, the stapes, and that worked very good. I developed also in the university hospital projects on temporal bones with piezoelectric vibrator usable with intact chain on the temporal bones. Then, in 1979, the first middle implant usable for human was built in Japan by Yanagihara and Suzuki and the Ryan manufacturer. They developed two types of middle implants. A partially implantable composed by an external audio processor in a BTE device, a receiving antenna and electronics, and a piezoelectric vibrator that had to be placed on the head of the stapes with removal of the incus plus or not malleus. This is a picture of the real device with external audio processor, the internal audio processor, and the piezoelectric vibrator with a little top, we should say, to put on the stapes footplate or head. Another model of their partially implantable middle implant with here the piezoelectric vibrator and a different mounting system. They have developed also a fully implantable middle implant with a rechargeable battery, implanted electronic, and the same piezoelectric vibrator with a microphone under the skin of the auditory canal. This fully implantable was implanted in animals, never in humans. You can see here a picture of this fully implantable implant, the vibrator, and it is a handcraft prototype, as you can see. So, in 1983, the team of Yanagihara and Suzuki's teams made approximately 65 implantation in patients with a partially implantable for the approval study for the implant. And they got the approval study of the Japan Ministry of Health in 1993. The implant was indicated in sensorineural mixed and conductive hearing loss, but in canal wall down or canal wall up approach. But in fact, they had to stop the technical definition, evolution of the implant to get the approval by the ministry, and they stopped it too early. That had as consequence that the output level of the implant was insufficient, and because of that and the need of incus removal, finally this implant was stopped and is no more implanted. Another model was developed in Germany by Zeder, a fully implantable middle ear implant with a piezoelectric vibrator and a rechargeable battery. The vibrator is ended by a rod which should be implanted on the incus, on the long process, on the stapes head, or with a piston, for instance. This device was approved in the European community and proposed at 22,000 euro. It was implanted in about around 50 patients only in Germany, with a problem linked to the conception of the device because the microphone was placed under the skin of the auditory canal. And when the vibrator stimulates the ossicular chain, there was a feedback that obliged, in fact, to remove the Malleus head to avoid feedback. And finally, this device stopped also. Another one, the Soundtech, very different, more simple, a very small magnet fixed in the incudostapedial joint after opening of the joint, and a stimulating coil in the auditory canal in a deep ear mold. This device was used in USA from 2000 to 2004 for mild to moderate hearing loss because its power was limited and, in fact, didn't give real advantage compared to conventional hearing aid because of the ear mold. And it was stopped in 2004 because of adverse effects of the implanted magnet when the device was turned off. And last project was stopped, this one developed by Cochlear and Phonak, the DAX, which is a very strange device with a very complex ID with vibrators that should be implanted in the middle ear with two stapedotomies, one to stimulate the inner ear, one to close the airborne gap, a very strange system. And in fact, it was implanted only in 4 patients and stopped quasi immediately. After this cemetery of dead devices or projects, we can speak now of the actually available middle ear implant. That means the Vibrant Sound Bridge, the MET Otologics, the Carina Otologics, and the Envoy ST middle ear implant. The Vibrant Sound Bridge is approved in Europe and in the USA. It is an electromagnetic, partially implantable hearing aid, needing only 1 point of fixation of the vibrator in the middle ear, and the actual price in Europe is 9,000 euros. Is composed of an electromagnetic vibrator which is fixed in the middle ear, an implanted receiving coil, and an external audio processor. The interest of the implant is that the magnet in blue is in a container between 2 elastomer balls in red that acts like spring, and the stimulating coil is just beside the magnet. And when the magnet moves in one direction, the spring pushes it back in the opposite direction, and the spring pushes itself the titanium container. That means it is an inertial vibrator. It can vibrate alone without being fixed in 1 point in the middle ear. That allows to implant it with only 1 point of fixation in the middle ear, the point that you want to vibrate. The implant is composed by the vibrator itself, the demodulator, a receiving antenna. It has a very simple design, very soft design, which is good for reliability. The audio processor contains the battery and the electronics that allowed upgrading of the implant by changing only the audio processor. The sound bridge should be implanted on the incus in the sensory neural hearing loss via a transmastoid facial recess approach, like in this view, or by an auditory canal approach, like in this view. In 2003, we started the indication in mixed hearing loss with sound bridge implantation in otosclerosis with a combined surgery with a stapedotomy piston procedure and a sound bridge implantation in the same surgical procedure. The sound bridge should be also implanted on the stapes itself directly in the absence of incus or malleus in chronic otitis sequelae, for instance, or since the idea of quality in 2005 on the round window membrane in the round window niche. This is the field of indication in sensory neural hearing loss and in mixed hearing loss, which is quite a broad field of indication. Other actually available middle implant, the MET and Carina by Autologic, they were created by Frederickson. There are electromagnetic implants with an electromagnetic stimulator, vibrator, that needs 2 points of fixation in the middle ear, one fixed point with a mounting bracket and one vibrating point which can be placed in different locations in the middle ear. There is the MET, middle ear transducer, which is a partially implantable implant with an external button audio processor, an internal audio processor, and the vibrator. It is available in Europe for 10,000 euro actually. The other model in Autologics is the Carina, which is a fully implantable middle ear implant with a rechargeable battery, a subcutaneous microphone, and the same electromagnetic vibrator. This vibrator is, as you can see, not very well, but you can see it's a more complex mechanical device than the sound bridge. Here the MET, here the Carina with the microphone, the battery, the vibrator, and the receiving antenna. The battery is implanted battery of the Autologics Carina is designed to last a minimum of 12 years with daily recharge. And the recharge is done with this device 1 hour per day. Here, this is, I'm sorry, the screen is very dark. It was operative view of the Autologic middle ear implant with the fixation of the rod on the body of the incus ear. The Carina and MET Autologic should also be implanted in mixed hearing loss. Here, in sensory neural hearing loss, the vibrator is implanted on the incus. In mixed, it should be implanted on the stapes head, on the round window membrane, or on the stapes footplate. This is the indication field of the Carina. Last implant, the Esteem Envoy. It is a very, very interesting device, a fully implantable middle ear implant with piezoelectric transducer with a battery lasting 7 years without recharge and using the tympanic membrane and the external auditory canal and pinna as a microphone. The Esteem is composed by the battery and the audio processor, the sensor, and the driver, which are technology, piezoelectric, that means sensor transform vibration to electricity and driver electricity to vibration. The sensor frequency response mimics very precisely the frequency response of the displacement of the incus in function of the frequency with a roll-off over 4 kHz. And the driver also mimics very precisely the footplate displacement in function of the frequency. This is the field of the indication of the STEAM envoy, quite large also. What are the results? The more documented are for the sound bridge, with actually more than 2,000 patients implanted in the world. Complications of the surgery are well documented in papers or in our experience on more than 100 cases. The only complication is in 8% of patients a mild sensory hearing loss due to implantation. What are the results in sensory hearing loss? There was several steps in this result. The first result is that the implantation do not deteriorate the hearing for the group. This is the mean post-operative hearing in this study. The second information was the hearing aid. The implant gives improvement of the hearing threshold in sound field. You can see for the French multicentric study with unaided and aided thresholds. This results for high frequency hearing loss, unaided, aided. One step more was that the implant gave an increasing gain with the increase of the severity of the hearing loss. That means the more the hearing loss is severe, the more the implant gives gain. Subjective satisfaction of the patient is elevated in, with the middle implant. This is our results in the Coast Clinic. High frequency hearing loss, no significant deterioration of hearing due to the surgery. This is the mean hearing gain in sound field with around 30 dB gain of, on mid-high frequencies. Patients are very satisfied, have a high rate of subjective satisfaction for different items, and with a HAFAB, which is a standardized questionnaire for all hearing aids, the scores of time with difficulty with the implant are quite good. One step more was to compare sound bridge and air conduction hearing aid with, in this study, a superior gain for the sound bridge compared to the air conduction hearing aids. This was confirmed by different studies here in the USA, sound bridge versus hearing aid, and the more recent this year, comparing the modern air conduction hearing aid and the sound bridge. The sound bridge is always superior, gives a superior gain. Not twice superior, but superior. One step more, after functional gain, after approval of sound threshold, this is speech recognition with, in this study, demonstration of speech improvement compared to unaided condition with the implant in quiet, in our experience, and in noise too. Garin developed very interesting studies comparing speech recognition in noise, unaided, and with the implant, and showed that the sound bridge improves speech recognition in noise. One step more is to compare speech recognition with the BTE and with the sound bridge. And as you can see, here's the BTE, here's the sound bridge. The sound bridge do moderately more better. And this is the results for speech recognition in noise, here unaided with the BTE and with the sound bridge, with a more modern BTE that you can use actually. So, as always with middle ear implant, the subjective satisfaction is superior to the implant in black compared to hearing aid in white. In this study, it's the same thing, hearing aid and implant, and the subjective satisfaction is always superior with middle ear implants. A recent study demonstrated that the long-term use of the implant do not deteriorate hearing compared to the evolution of the non-implanted ear. It was frequently a frequent fear at the beginning of the use of middle ear implant. Does they deteriorate the hearing? And it is proven now that not. And last step, the cost per quality study. It's a very interesting and sophisticated study to appreciate the balance between the cost and the effectiveness of all health cares, cardiac surgery or cochlear implant or middle implant. And in case of impairment of hearing with external otitis, it is proved that the middle ear implants have a more favorable effectiveness ratio than the ratio of the cochlear implant in total deafness. That means middle ear implants are cost effectiveness validated. Then the bilateral implantation was done, showing that you give the subject a bilateral hearing, and I'm sorry, but I have to go further. Then in 2003, started the indication in mixed hearing loss, then the indication with implantation of the round window, giving in mixed hearing loss such results. So, second implant, the MET and Carina otologics, they are approved in the European community and with a less important number of patients. First, they do not deteriorate hearing. Second, this is the mean gain provided by the MET and Carina. They improve speech recognition. They are appreciated in a self-assessment scale. And they can also, this is for the Carina, the functional gain, the possibility for mixed hearing loss. And they are now approved in Europe for mixed hearing loss, giving such results for this patient, for instance, with implantation on the round window, such gain. A comparison was made between the Soundbridge and the MET otologics, and in fact, the functional gain, the hearing gain are very comparable. Last one, the STEAM Envoy. I described you actually, there is about 150 patients implanted. He is approved in the CE since last year and is starting in Europe and different countries. They have a very interesting way to present results. That means if we consider hearing improvement, you may see here that most of the subjects have a benefit of this implant just for improvement of hearing threshold. 96% of the subjects have improvement in hearing threshold. For speech recognition, compared to hearing aid, you can see that most of the subjects, 80%, have a benefit equal or superior to the one provided by conventional hearing aid. Another speech recognition test, also 80% of the subjects have a benefit superior or equal to the one provided by conventional hearing aid. Another result for other speech recognition test versus hearing aid, most of the subjects have a benefit equal or superior. 20 have a result inferior to the one with conventional hearing aid. So, in conclusion, middle-ear implants have now proven to be safe, reliable, and effective hearing aids. The first indication remains sensorineural hearing loss, with a very big competition with air conduction hearing aids that had to move when the middle ear implants arrived. And because of the arrival of middle ear implants, the conventional hearing aids